So now let's move to the transform option over here. So we can see that you have these variables listed over here. Okay, so CHAS is say two elements, 0 and 1 distinct elements, but it's numeric type, right? So we want to change it, say for example, into a class-based data or something like that. So this tab, that is the transform tab, is the most useful option for us, right? So rescale is for scaling, right? Impute is basically for missing value treatment. Recode is to just change the code. So if you have male, female, you can make it 1, 0 and so on, right? So it's for that. Cleanup is to remove a variable from the data, or maybe selective removal of data, right? That's what cleanup is used for. Okay, now within rescale you can see that there are normalized options, recenter, scale, right, and so on, right? And there is order also, whether you want to convert it to rank order or interval scale and so on. So let's look at the CHAS variable, and from that perspective what all things we can do, right? So obviously there will be a lot of things we can do, but we are just limiting ourselves to some specific things as of now. It's highly recommended that you go ahead and explore as much as possible in the transform option, because this is what is going to be the core element, the transform functions over here, that will help you to exercise a lot of control on your model building aspects. So let's say the recenter option, again just a quick brief, is just to center the data around 0. So scale is just to limit it between 0 to 1, kind of how you have your marks as percentage between 0 to 100. Then you can have the around the mean also. You can have natural logs, log to the base 10, and the matrix components also. Not all of this is applicable for every data type and for your specific curriculum as well. The rank option also, the interval option also. So let's say we want to convert a variable into an interval scale, right? So maybe group it, right? So you can select the number of groups. So, but now for say MEDV it makes more sense, not for CHAS. So let's say we can click over here, or we can rank also, but ranking MEDV won't make sense. It will make sense for CHAS. Okay, because you want to rank it, convert it into a factor. So you can just say rank order, just say execute. You'll get a new variable, right? So it will have some component of CHAS as a description. So RRK underscore CHS. Now obviously to have a look at this, you will have to go and explore. Just say summary. So we were just trying to do some transformations just to see how it looks. So obviously go down, last variable, yeah, and execute this. Right, so we are seeing this. This is what has happened to that data. Might not make sense from an application perspective, right? So we are just trying all the options which are available over here. Again, go back into transform, select MEDV. So you want to recenter it, that means you want the mean around 0 with a standard deviation of 1. Execute. So you have this new RRC underscore MEDV. Go back to explore and select this variable. See the box plot. Just say execute. You can see the transformation now. Comparative would have made more sense, right? So let's select MEDV as well, so that we can compare these two, and press execute again. Okay, so now you can see that we have the original MEDV and we have the transformed MEDV. There is no change in the form of the data. The only thing is that this one is centered around 0 and that one is centered around the 22.5, something like that. Now these transformations are required more from the perspective of making it easy for the algorithm to basically consume the data, use it for basically arriving to a conclusion. Like for example, if you're using an ANN model, right? So like a child which is learning from the data, or like a child who is eating food, right? It makes more sense that a 2-year toddler, you would obviously boil or overcook the rice or whatever food you're giving so that it is easily digestible. As you grow, you don't do that. If you want to remove these two, then you can just select this is direct shift and control, or control and select, and you can just use it in the cleanup. Okay, when you press the cleanup, it got deactivated. You're selecting it and using execute. You need yeah, but incidentally it prompted us that you want to delete MEDV and CHAS, and we say yes to that, and that's where we went wrong. So it's lost in the data. Let's just go back into the data and check. Okay, it's there. Press execute. We don't see any change as such. Sometimes you might need to refresh, right? So if you have done something like this, so you don't have the core variables. So I'll just go back again. So let's remove these variables again. Press execute. So this time, oh, we had not selected delete selected, we had said delete ignored. Okay, so those are the ignored variables which got deleted, right? So we don't want that to happen. Again, next time we have to be a bit cautious. But now we have lost the core variables, right? So we need to go back and see how we'll get that data. So let's try to get the data back. So it's not getting refreshed. So as a workaround, let's do one thing. Let's select some other data. Okay, just press execute. Close it. Select again the data of our choice, that is the mass data set, and again press and execute. So this would be a fresh load of the data. Okay, so now we got the data again. So there are times when you'll have to work around like this. You have to be a little bit intuitive as well as innovative. So now you have the data again as you wanted. So let's say we want to do the interval. So we'll go on MEDV. Let's change the number of groups. So say we want 10 groups. Select MEDV and press execute. So this is your new data, transform data. You can go back to explore and see how this data looks, right? So just keep this selected, go to explore tab, summary, execute. Okay, you have to select summary again. Okay, summary. Okay, now you can see this, the new variable, right? Now you will see it between 0 to 9. The reason being that you convert it into classes. So these are the numeric form, and that is why it is showing like that. So we can go into transform again. Can use recode. Over here we can select the number of classes and how we want the binning to happen. Whether we want it to happen with quantiles, we want to have equal width, right? So let's keep it, say for example, with quantiles or with equal widths, depending upon what we want to do finally, right? Equal width means the classes will be formed basis threshold value which have equal widths. Okay, and then say I'm making it 5 and then execute. So you have this new column or variable. To see this, we'll go back to explore, press the summary, execute, go down and see. Right, so 4 to so it is almost 5 to 14, 14 to 23, 23 to 32. This is equal width, roughly equal width, right? So the frequency or the elements contained in between these classes has different frequencies, right? So the intention was to make sure that the class thresholds are constant or equal width. On the other hand, if you want the frequency distribution in these classes to be equal, then you'll have to select something like the quantiles, which will make more sense, which will bifurcate the data, right, accordingly. So I'll say, so I'm doing it on this one, which we have already transformed, and saying it as category and execute it. So it's saying only numerical data permissible because we have already created into class, so it's not taking it. Let's say it for MEDV. As categoric, and let's say want it is quantiles. Select again the variable, execute. Okay, so we have got rid of that error and now we have that data. Again press and summary execute. Right, so you can see the frequency distribution over here is quite constant now, right? So we did almost the same thing, BE5 MEDB, BQ5 underscore MEDB, but only thing is that in this case we have got the frequencies to be distributed in a constant form. So the intervals have been selected in such a way that the frequency distribution, and that is because of the quantiles being selected. We can do a cleanup of the variables now. We don't need this transformed variable, so just do a cleanup. Say execute. So delete selected, be cautious. Execute. Say yes. So if you want to delete missing value, you can select this part. If you want to delete observations with missing value, you can select this. When you say delete missing, only that variable will be deleted, and this is where the observation, the rows will be deleted wherever a missing value is present. Now you have the impute option wherein you can replace a missing value or an NA with a fixed value, the mean of that column, the median of that column, the mode of that variable, or a constant value. That is completely your choice. In this data, we don't have any missing value, so we cannot do it. It doesn't make sense. But in most of the data set, you will have missing values and you will have to use imputation techniques. So that obviously you can do it through this option over here. So we have done the transform option. There is a lot of scope to do it